This is a particular type of exam question that turns up from time to time in applied maths in question 1, linear accelerated motion, and I would encourage you strongly to read the question and try it yourself before looking at the solution, because it's a deceptive question. It looks easy enough at first sight, but there is some tricky algebra involved towards the end, and that's the reason why I'd like you to try it, because it's kind of question you can look at and understand fairly easily as I'm doing it. But if you try it on your own, it's often a different story. Anyway, we'll talk through the solution. So what we're talking about basically is a car that starts at rest down here, and if we draw the velocity time graph, we see he starts at rest and he accelerates up to a speed v, a constant acceleration. Then he stays at this speed for a while and he finally decelerates back to rest again. And we're given one statement and we're asked to prove another statement. We're given this statement here that the average speed for the journey is 5v over 6, but we're trying to prove that he stays at constant speed for 2/3 of the journey. So this is what we got to prove, that basically this time here, we call it t2, that's 2/3 of the total time. Or to put it in algebra language, what we're trying to prove, and it's important again to be focused on the answer you're looking for from the very start, so you don't lose sight of what you're doing. What we're actually trying to prove, in other words, is that t2 over the total time, which is the 3 times together, is 2/3. Now, our starting point. Lots of places, I'll talk for a minute about places where you can go wrong as opposed to the right thing to do. A place you could go wrong here very easily, I suppose, which would be very easy to happen, is to bring in accelerations. You know, start using v equals u plus at for part 1 of the journey and so on. There's absolutely no need for that, because the whole emphasis of the question, if you read between the lines, is they're only talking about average speed, which is distance over time, so there's distance and time mentioned. And yet again, we're talking about the part of the journey, 2/3 of the journey is at a certain 2/3 of the journey is t2 over the total time. So at every stage in the question, they only mention speed, distance, and time. So that's kind of a clue, as it were. You know, we don't need to get into accelerations really, because it's only introducing extra variables. So watch out for things like that in an exam to keep your equations, your unknowns down to the minimum. So let's get started. We're given average speed, which we know from maths is simply distance over time. And we're told that that's 5v over 6. Now the time is the easy bit. Under the line, time is actually the 3 times added together, t1, t2 and t3. The distance, the total distance above the line, well, we've got a way of getting that, and that's the area under the graph here, under 1 plus 2 plus 3. So you get those 3 areas. The first one is the area of a triangle, area of a rectangle, and another triangle. Half the base by the height, length by width, half base by height again, and so on. The next thing then is to tidy up the algebra. We have a half and a half here, so bring those two together and group them. And when you get your answer for the total, this is the total distance, put it in down here. And then you cross multiply. So top by bottom here is top by bottom down here. And if you work all that out, and you find that it reduces to simply t2 is 2 into t1 plus t3. Now that seems to be a dead end for the moment. We can't really go any further with that until we realise what we're looking for. Again, be focused on what we're looking for. We're looking for this. We're trying to prove this statement over here. So if we could prove somehow that those two were identical, well, then we'd have proved it, that this statement down here and this statement up here were identical. So what we can do is work backwards a bit with the finishing statement. Cross multiply over here, and if you cross multiply, you get the exact same result. t2 is 2 into t1 plus t3, which is exactly what we got down there. Now again, as I said, it looks short, it doesn't look too difficult on paper, but it's the kind of question when you try doing it yourself, you can get tied in knots very easily. So I've produced, there's a few ways to do this, to go about doing this, but this is certainly, I think, one of the quickest ways you can approach it. And that's the end of this lesson.